Right. So we were trying to find the probability of B, which we found to be 1.25x, and then we also wanted the probability of A intersection B, which I already got up here. So it's 0.5x. Let me see. And they are right. Okay. Hence find the value of x and complete the Venn diagram. Okay. Okay. So the intersection, I'm going to do this in black, is 0.5x. B is 1.25x, so 1.25x minus 0.5x is 1.25 minus 0.5 is 0.75, and that's what goes in here. Okay. The probability of A was x, so it's x minus 0.5x. This is a 1, so that's just 0.5x. That goes in here. The union is 0.84. Oh, we can probably... Anyway, if the union is 0.84, that means the circles is 0.84, and probability is always out of 1. So that means out here is 0.16. And then to figure out what x is, if I add 0.5x plus 0.5x plus 0.75x, that's the union, so it should equal 0.84. 0.5 plus 0.5 plus 0.75 is 1.75x equals 0.84, and then divide by 1.75 on both sides. So x is I'm getting 0.48 for x. And then complete the Venn diagram. So it's 0.48 times 0.5, which is 0.24. So this is also 0.24. This was 0.16. And this is 0.75 multiplied by 0.48. That's 0.36. So these three should add up to 0.84, and they should all add up to 1. I'm just going to check. So 0.24 plus 0.24 plus 0.36 is 0.84, plus 0.16 is 1. Yep, they're right. Okay. Now, state whether the events are independent. Now, I said this when I taught you this. You can learn it, but for some reason it will not stay in my head, so I need to try and remember. Okay, that's my conditional probability. This one then is the probability of A occurring given B has already occurred. So the probability of A occurring given that B has already occurred. That means whatever happens in B has an effect on A. But if they're independent, that's not the case. So, if they're independent, then this equals the probability of A. Yeah? So the probability of A occurring given that B has already occurred, if they're independent, it doesn't matter that B has already occurred. So the probability of A given that B has occurred is the same as the probability of A. So then that gives us the probability of A equals the probability of A intersection B over the probability of B. And then I can rearrange that, like multiply across by the probability of B. So I get the probability of A intersection B equals the probability of A times the probability of B. And that's the formula that you can learn off. It just won't stay in my head. So the probability of the intersection, what was that? 0.24. Sorry, don't know why that's in black. 0.24. The probability of A, now the probability of A is both of those, so that's 0.48. Isn't it? 0.2, yeah. And then probability of B is the other two, which is 5.6. So we'll check if these are equal. Mm-hmm. 0.48 times 0.6 is 0.288. So they are not equal, which means therefore A and B are not independent. Yeah, so I made that longer by not knowing the formula, but I could figure it out. So either learn it or figure it out, it doesn't really matter. So in a factory, 8% of the items produced by a certain machine are defective. 10 items produced by this machine are selected at random for inspection. Okay, so the probability of being defective is, just do 8 out of 100. So the probability of being okay is 92 out of 100. 10 items are produced by this machine. Find the probability that exactly 2 items are defective. Exactly 2. Okay, so we have 10. We're going to choose 2 that are going to be defective. The probability of being defective is 8 out of 100, and we would like 2 of them to be defective. The probability of being okay is 92 out of 100, and we would like 8 of them to be okay. So 10 choose 2 multiplied by 8 over 100 to the power of 2 multiplied by 92 over 100 to the power of 8. 4 decimal places is 0, 1, 4, 7, 8. Find the probability that at most 2 items are defective. So that's 0 defective, or 1 defective, or 2 defective. So same thing, we just have to do it 3 times. Well, 1 is already done. So we've 10 and we want none to be defective. Probability of being defective is 8 over 100 and we want none of them. Probability of being fine is 92 over 100 and we want all 10 to be fine. Or is plus. Of the 10 we want 1 defective. Probability of being defective and we would like 1 of them. Probability of being okay and we want the other 9 to be okay. And then or, and this one is 0.1478, and I'm going to hold all the decimal places, so I'm going to store it in A. Okay, right, we'll do this one. So 10 choose 0 times 8 over 100 to the power of 0, probably didn't need to do that, multiplied by 92 over 100 to the power of 10. So this is 0.4343 and there's more. So I'm going to store this in B. Plus 10, choose 1, multiplied by 8 over 100 to the power of 1, multiplied by 92 over 100 to the power of 9. So it's 0.3777, and again there's more. So I'm going to store this in C. And then this is plus A. Okay, so then we do alpha B plus alpha C plus alpha A. And to 4 decimal places, I am getting 0.9599 for that one. Oh, and that is it.